IB Environmental students. In class, we started human populations, topic 3, and now we're going to continue forward with a couple objectives we didn't do in class. Let's begin. So, we're going to start with a certain type of model called an age-sex pyramid. It is going to analyze the population by looking at males versus females, sex, and the proportion of the population at each age level. There's 3 main age categories that we'll usually divide out by. Pre-reproductive age, which is before puberty. Reproductive age in those middle years when those individuals potentially could also have more children. And then post-reproductive, when they're getting to a mature age and even what we would consider the elderly way past them. And when we look at these age-sex pyramids, what we're going to be talking about are how do they relate to how the population will grow in the future, so we could predict changes in the population. And we have mainly 4 categories: rapid growth, slow growth, zero growth, and negative growth. And so we're going to get some examples. You should do some drawings of the examples for yourself, and you should also give a named location that has that type of growth. Let's begin. So here's our first comparison. This is an age-sex pyramid. We'll see that the males are on the left, females are on the right, and each block is a different age category. This is infants and so forth. Remember, this first age category is 0 to 14. Second age category, again, that reproductive age group is in yellow, 15 to 44, and that older age category up to the elderly is 45 up to 85 plus. So what we'll see here is there are a lot more what? The younger group. And so over time, this younger group is going to get older and get to the reproductive age, and they are then going to have more babies. So this population is going to grow a lot and fast because the bottom part's really big. So if we looked at a future age-sex pyramid, it would look even wider. And the places that have this type of population growth are here. This one is slow growth. We don't see the bottom part where there's babies as big. We see some larger spot than the elderly that is in this category that is reproductive. So this is going to grow, right? It's going to funnel up the number of individuals, but not quite as fast as this one. We're going to practice these in class a bunch. Zero growth, notice that this one is way more even if we think about how wide it is. There's not that many more individuals that are young versus in the middle age group versus old. They do die off. Remember, our survivalship curve is late loss. Don't forget to be drawing some brief examples of these shapes. Okay, these growth things all look like triangles where the bottoms are bigger. And if it's a triangle shape, it's going to grow. This one's less triangular, more almost like a rectangle. It's not going to grow much. We call that zero growth. These places are having zero growth. This means that they are having replacement fertility. Now notice this really cool example of negative growth. Negative growth, we can see that it is narrow. It's an upside down triangle. It's narrow on the bottom. There are less infants than there are elderly. So what's going to be interesting in this population is what's going to happen when this gets really big and this is super, super tiny. We have to think about why is this the case? What will it be like in the future? Here's some places that have this negative growth. Okay, let's apply some of these things. Well, we can apply and think about, well, why were those growth in the age-sex pyramids the way they were? And to do that, humanitarians and scientists came up with this thing called the demographic transition model to describe what period in industrialization is the location. We could relate this to is the place LEDC versus MEDC, and how far along is it in development. So overall, countries become industrialized first, and when that happens, first death rates and then birth rates will decline. So the first stage in the demographic transition model is called the pre-industrial stage. And we're going to look at graphs, and I'm even going to give you a graph for you to have in your binder later of this. The pre-industrial stage will be described as harsh living conditions. Think Middle Ages for the most part. There's not much out there to help things be nice living standards. You wouldn't necessarily want to go living there. You might get malaria or something. And there's large births and a large amount of deaths to compensate each other. The transitional stage is really interesting. That's when the people in the area really want to have better living conditions, and they're doing their best to have the ability to make things better. They're going to industrialize their area. They're going to try to get better healthcare and food availability. Population is going to start to skyrocket because they're going to keep having lots of births, and maybe the deaths will start to lower. So now we are having a lot of population growth. In that time period. When things begin to be industrialized, the population will slow down a little bit, and then births will still be a little bit bigger than deaths, but not quite as big as this transitional stage when the whole overall population is just skyrocketing and exploding. The last stage is called post-industrial, where living conditions are now really nice, and overall, the population has gotten to zero population growth, if not even maybe negative growth. And so this would be zero population growth, which is about 13% of the world, where the births are equal to the death. And then don't forget that some places, even the births start being less than the deaths, and that's when we start having this decline in the population. And scientists and humanitarians are thinking, is this maybe a new stage entirely, a stage 5? Okay, so this is what this visualizes as, where we can see this pre-industrial where births and deaths are kind of equal. We get transitional. The place is doing a lot better. We have better living conditions. Deaths going down. We got medicine. That's nice, so I don't die when I get a cut or get stung by a mosquito. And then overall, my population starts to increase because I'm still having lots of babies, and I'm not compensating for the fact that less people are dying. And then I get even better living conditions. Maybe I start having a few less babies, my growth starts to slow down, and then I get industrial, and maybe my growth totally slows down, even decreases. So what's interesting is we can think about where are different actual locations within this stage differences. We'll notice that we can really tie this to different places, but what I want to note is a lot of people get stuck in the middle, those transitional stages where they're having a lot of births, and even though they're having not a lot of deaths. And this is tough because one of the biggest things we'll talk about is, well, how do we lower this population explosion? How do we tell people, and can we tell people to have less babies? But what is the cause that they're stuck? Well, they still need a lot more workers. They might not have a lot of capital or resources. Their economic and politics are maybe funky. Maybe they have certain cultural or traditions that cause them to still have a lot more babies. And maybe they even still have a high death rate still. So a lot of what's important is you know that they're getting stuck. A lot of places get stuck in the middle. So now we're going to talk about, like, what do we do with all this information? How do we deal with this? Well, we'll start to use this information to model into the future so we can try to make solutions. And the goal is to predict the optimal number of people that can sustainably be supported on the planet without further environmental degradation. And we know that this is called carrying capacity. And what we'll do is we can use this to predict ways to reduce birth rates. And so the first thing is family planning. But not everybody is going to feel the same about this, and is it ethical to tell different places to have family planning? We could try to empower women. When they're educated, they have jobs or have more rights, it's less likely they'll have as many children. We can also try to help people economically, give economic rewards for not having as much children. Think about China's one-child policy, or even have penalties when they have too many children. And then what we need to think about is, if we're using models to predict the future, are these models perfect? We can evaluate the limitations and strengths of them. So some models are way different. They can't see the future, but they are predictive, and we really need to think about how powerful those predictions are based on current information and calculations that we'll practice in class. So we try to model the future. We usually do it with computers, and the more data we have, the more accurate. So here's an example. You don't need to write anything down, but notice how we have this age-sex pyramid. This was from 1990, and what we can do looking at this is we have less at the bottom. Do you think there's going to be some growth or some decline? Well, initially there's going to be some decline at the top, and we can see this bump slowly moving up. 10 years later, it's moving up, and then overall 10 years over here. But is this model perfect? Not really, because over time it looks like they had a lot more births at the bottom due to some sort of environmental factors that were happening in this location. But we hope that the predictions could work. This one, we can see that in 2000, we think we saw this data in this location, and then we can predict that group here will move up to older age bracket, and we'll see that here in these predictive models. Same thing here. Here we can see a place potentially that's going to have rapid growth, and we can see here what that rapid growth would look like 25 years later. We'll practice age-sex pyramids more in class. You didn't need to draw anything for this section. But what I do want you to note, which is kind of interesting, growth is a problem potentially, but so is population decline. And if we have population decline, which we are predicting in about 39 countries by 2050, for example, Japan is already having issues with population decline. If this happens too fast, there's a lot of issues. We might have in that location too much people and they're consuming public services and healthcare and social security too fast, and there's not enough young people to support them. And because there's not enough young people, we might have labor shortages. We might start having more immigration to support the older population. And is there going to be unrest about this? This is also something that's affecting the United States. So overall, good job, you guys. You did a wonderful job. Hopefully you got some of these models down, and we will practice them, of course, in class. Bye.